Okay, we're now going to do part 2 because the next question is what is the joint reaction force? So if you look at this diagram, this is the muscle force that's acting on my limb or my upper arm. I also have 15 pounds acting in a downward direction. I also have 10 pounds acting in a downward direction. The joint reaction force is Newton's third law. It is the body's equal and opposite reaction to the sum of the forces acting on the limb. To calculate this joint reaction force, I will need to find both the x and y components. So I will sum the forces in the x direction to find the joint reaction force in the x direction, and the same thing for the y, and then I will use Pythagorean theorem to find the magnitude. So let's begin by first summing the forces in the y direction. And actually, let me just give you one little tidbit. I know that my muscle forces are large, much bigger than the external load or the weight of the limb. So my joint reaction force is going to be similar in magnitude and opposite in direction to my muscle force. So I'm expecting my joint reaction force to look something like this. In order for a vector to look like this, it must have a negative y component and a positive x component to get a vector that looks like that. So let's begin. I already know all three forces that are acting in the y direction. I have a muscle force that's up, body weight of the limb that's down, and external load that's down, and some unknown joint reaction force in the x direction. I sum those equal to 0 because I'm in equilibrium. So my rotatory force was 97.5. So my muscle force in the rotatory direction plus weight of the limb plus external load plus unknown joint reaction force in the y direction are equal to 0. This is 97.5 pounds, and it was in an upward direction, so it remains positive. The weight of the limb is 15 pounds, but it's in a negative direction. So I will add in a negative 15, or if you choose to just say minus 15, that's fine, and a negative 10 pounds, plus an unknown joint reaction force in the y direction equal 0. Put that in as an unknown and then solve for that. Don't make any shortcuts or you're likely to get into trouble. So if I add positive 97 minus 15 and minus 10, I will have 72.5 pounds plus an unknown joint reaction force in the y direction equals 0. So my JRF in the y direction is equal to a negative, because I move it over, 72.5 pounds. I go back to my little cheat sheet. Did I end up with a negative joint reaction force in the y direction? Yay me, I did it correct. Next, I will sum the forces in the x direction equal to 0. Weight of the limb and external load have no component in the x direction. The only component in the x direction will be the muscle force, which I have not yet calculated that. So I now can use my sine of 20 degrees is equal to the muscle force parallel over the resultant muscle force, solve for muscle force parallel, cosine of 20 degrees, or you could do it another way if you chose, as long as it worked mathematically, times 285 pounds was my resultant muscle force, and I will get my muscle force in the parallel direction equal to 267.8 pounds, close to that, depending on how you're, I'm sorry, wrong. Oops. Oh, no, that's right, yeah. 267.8 pounds. Now, when I plug it into the equation here, I always have to pay attention to what direction it's in. So this muscle force, remember we took time to make sure our arrows were in the right direction. That muscle force goes to the left. So I'm going to plug it in as a negative 267.8 pounds plus an unknown joint reaction force in the x direction equals 0. And I now solve for JRF, and I will get a positive 267.8 pounds. Did I expect a positive? Yes, I did. So I've got my two components. I'm going to take a break. Third video, I'm going to show you how we bring those together. That's the end of this portion.